the skeletal and muscular systems. The goal of this presentation is to learn how the skeletal and muscular systems contribute to the life of an organism. The objectives are to identify functions of these systems, to identify structures of these systems, to identify processes associated with these systems. Dr. John R. Blanton, Jr., Assistant Professor of Animal Science, has over 8 years research experience in the areas of growth and development with comparative studies between humans and animals, and has presented at international medical and education conferences. Muscle biologist and 4-time national championship collegiate meat judging coach, Dr. Mark F. Miller, Professor of Animal Science at Texas Tech University, has over 21 years teaching experience and a national reputation in muscle and meat science.
Most animals have a skeletal system that is very similar to humans. All skeletal systems consist of 2 major components. The first component are the bones of the axial skeletal system, and then there's the second component, which is the bones of the appendicular skeletal system. When we look at the axial skeletal system, the first bones that we see are the bones of the skull. Immediately following the bones of the skull are the bones of the vertebral column. The first bones within the vertebral column are the cervical vertebrae, followed by the thoracic vertebrae, then the lumbar vertebrae, followed by the sacral vertebrae, and finally the coccygeal vertebrae. Also within the axial skeleton are the bones of the rib cage and of the sternum. When we look at the appendicular skeletal system, there are 2 major components to it: the bones of the hind limb and the bones of the forelimb. When we look at the bones in the forelimb, the first one we'll find is the scapula, immediately followed by the humerus, the radius, the ulna, then the carpal bones, the metacarpus, and finally the phalanges or digits. When we look at the bones of the hind limb, the first bones we'll find are those of the pelvis, followed by the femur, then the patella, the tibia and the fibula, the tarsals, the metatarsus, and finally the phalanges or the digits. While humans and most animals share a similar skeletal system, there are some small but significant differences. For example, the human skeletal system is upright and is meant to walk on 2 legs, and is what we call a biped, whereas a cow would walk on all 4 legs and is a quadruped. Another difference between the skeletal system of humans and those of other animals is how the bones have fused through development. For example, if you take the bones of the hands, it consists of many different phalanges that gives us a lot of different movement and the ability to grasp things. But if you take a look at the bones of the cow's foot, those phalanges have fused together into shorter, smaller bones, which allows the animal to apply more force onto its foot. Another example of bones that have fused together is in humans. Whereas other animals have many sacral vertebrae, in the humans those vertebrae have fused together into one single sacrum. Another skeletal difference you'll find between species is the absence or presence of bones. There are species difference in number of vertebrae you find within the spinal column. Another example would be the existence of a bone that connects the appendicular skeleton to the axial skeleton. In humans, we have a clavicle, which is connected from our scapula to the sternum. However, in 4-legged animals like a cow, that bone does not exist. The bones of the skeletal system have many different shapes. For example, the femur and the humerus are long bones, whereas short bones will be bones in the hand, the phalanges. Flat bones will be bones that are used for protection, like your ribs and your skull. And irregular bones are any bone that has a process sticking off of it, such as the bones of the vertebral column. Skeletal systems of all mammals share a similar function. Those functions would be protection, locomotion, blood production, and mineral storage. When we consider the function of protection for the skeletal system, we'll find that most of our vital organs are located within the flat bones of the skeletal system, which are some of the strongest ones there. For example, your brain is surrounded by the skull, which is all flat bones and are very strong. Another example would be the heart, which is located directly behind the sternum, another very strong bone that's meant for protection. The bones of the vertebral column provide protection for the spinal cord. Bones of the skeletal system allow for structural support, which is required for locomotion. Muscles are directly attached to those bones, and when we use those muscles to move the bone, we have locomotion. During the development of bone, a structure forms called bone marrow, and this bone marrow is found throughout the skeletal system, and is responsible for the production of elements of the blood.
Marrow also has another function, and that would be to store energy and nutrients and fat. We find that many of the bones in the ribs contain more lipid and fat for storage to survive when we have long periods of stress that go on, especially after severe injuries. We might be able to utilize some of that lipid to maintain our body weight and also maintain our body homeostasis. Finally, bones are excellent sources of storage for nutrients and mainly calcium and minerals that are necessary for body functions as we go through our life. Ligaments attach bones to one another and allow for the structural and movability necessary when you have a bone-to-bone attachment. Without ligaments' flexibility, we would not be able to move in the joints as we need to.
Within the skeletal system, where bones meet is termed a joint. An example of those would be fused joints, hinge joints, pivot joints, gliding joints, ball and sockets, and saddle joints. Fused joints can be found in the skull, pelvis, and sacrum in humans and do not allow movement, and is typically where two bones have fused together. Hinge joints allow movement around a single axis, much like a door hinge. An example would be the elbow, digits, or the knee. Pivot joints allow rotational movement around a single axis passing to the center of the bone. An example of these would be the movement between the first two vertebrae of the vertebral column. This pivot joint allows you to rotate your head from left to right. Gliding joints allow movement across the single plane, such as the many bones found in the wrist. Some joints, like the saddle joint, allow movement around two axes to form a circular motion. Examples include joints found between the carpals and the phalanges. Some joints, like the ball and socket joint, not only allow movement around two axes for a circular motion, but also allow movement on a third axis for rotational movement around the bone. Examples are found in the shoulder, where the humerus meets the scapula, and in the hip, where the femur meets the pelvis.
An important structural component of a skeleton is cartilage, the shock absorber of our system. Cartilage is the substance that cushions the impact in between those joints and covers the ends of the bones and allows them to move more fluidly against one another. It's also found in your nose. Also, you'll find it in your ears. In very young livestock and very young people, cartilage is found pretty much throughout the body.
Ossification is the process in which cartilage is converted to bone. Generally, in younger animals, the skeleton is primarily made up of cartilage. As we age, cartilage ossifies into bone. Bones grow in length at the end of the bones on the cartilage or growth plates. Hormones released cause these plates to grow rapidly, resulting in growth spurts. In a human, the pelvis acts like a bowl to support the organs of the abdomen, or in a pregnant woman, the baby. In breeding livestock, two prominent features of the pelvis are known as the hooks and pins, or the ilium and the ischium. During birth or parturition, in order for the birth canal to expand, the right and left sides of the pelvis must separate at the pubic symphysis. A large birth canal allows easier birthing. If the birth canal is not wide enough, a cesarean section is necessary. As females age, the pubic symphysis ossifies, which fuses the two halves of the pelvis together. This means the pelvis does not separate as easily.